My name is Andrew Jackson and I'm an evolutionary ecologist in the School of Natural Sciences in Trinity College, Dublin. My interests are very broad and span everything from explaining broad-scale patterns in ecology to conservation, epidemiology and population biology. But my real interest and love is in understanding animal behaviour and why it is that animals have evolved certain behaviours and certain strategies to deal with the challenges that they face in the world on a daily basis. For me, one of the most challenging situations that an animal can find itself in is in a complex social society. And when animals live in groups like this, there's a lot of potential there for cooperating and helping each other, but there's also the temptation for conflict, and animals have to have behaviours to allow them to negotiate and navigate this complex group on a daily basis. And one of the things that I use to understand this system is to develop computational and mathematical models. And this is because these systems are often so complex and there's so many feedbacks going on where my behaviour affects your behaviour, which in turn affects somebody else, which then might come back and affect my behaviour again. Trying to understand this in an experimental system is very challenging. So we will build basically representations of animals in the computer and then give them certain behaviours and try to understand how it is then that different interactions affect those behaviours and whether these behaviours are good for the animal or bad for the animal, essentially. And one of my all-time favourite pieces of work that we did was aimed at trying to understand the link between cooperation and intelligence in animals in societies. And what we did was we built a computational model that allowed individuals to interact with each other. And when these individuals interacted, they essentially had a choice. They could either help each other out and cooperate for a certain reward, or there was always a temptation there to cheat on your neighbour and to try and grab all the reward for yourself and leave them with nothing. And in order to allow our animals to make this decision, we basically imbued them with tiny little computational artificial neural networks, which are essentially simple little brains capable of acquiring information on their neighbours, learning what it is about learning about their neighbours and what they're likely to do, and then coming to some sort of decision or idea as to how they're going to behave in the future. And when we ran this model in a sort of big evolutionary soup, essentially, so we allow these animals to evolve different behaviours, we allow them to evolve different sized brains, we found that very clearly there was a very strong link between a need to be cooperative and a need to have the intelligence to let you be cooperative so that you can spot the cooperators and help them, and also so that you can quickly spot those that are going to cheat on you and you can avoid them. More recently, what we've been working on is a discovery we made that essentially animals don't see the world in the same way as each other. And what we found by analysing data on visual properties of various animals was we found that animals have a very different rate at which they can perceive the world. When we drilled down on this, we discovered that there's a pattern to it, that essentially large-bodied animals live a slower life and have an eye that's incapable of perceiving fine-scale differences in the environment, whereas smaller-bodied animals are capable of seeing an awful lot going on and their eye responds very quickly to the environment around them. And the real challenge now for us, after describing this pattern, is to explain, well, why is this, and what are the evolutionary drivers behind it? And this is again where we want to turn to computational models to build computer representations of this visual process so that we can explore and understand how it is that the pressures to acquire information and the challenges of dealing with that information in a brain, how this shapes the evolution of animal behaviour and what the consequences are for animals. I mean, is there a difference that big animals can't perceive the world at the same speed as smaller animals? How does it affect things like predator-prey interactions? And particularly for me, of course, I'm interested in how this might be affected by the challenge of living in a complex group like a shoal or a flock or a huge crowd of humans.